before start, hang on. I'd like to just inform everyone about your WA dates. Okay, I find my message. Okay, for AMAS, this time around AMAS is going to come first. Okay, so AMAS WA2 will actually be on week 6, Wednesday, 26 April. Okay, so it's over here. AMAS WA2. Okay, I'll tell you the chapters in a moment. I settle the dates first. Okay, then for EMAS will be on week 7 Tuesday. That is 2nd of May. Is this week 7? Yes? Okay, so 7 then down here is EMAP WA2. And yeah, I've changed what? The WA date. Cannot yeah. Because it's fixed throughout the entire level. Yeah. Is there a concern? For history, but each day maximum 2 WAs. Yeah. Other than history, is there anything else? I mean, this is school policy lah. School policy says each day maximum 2 tests. So I'm not going against the policy. It's just a coincidence that you have your EMAS WA2 happening here. Okay, I'm just going to write it big. Whoever manages this board, please go and update it. So 26 April, week 6, Wednesday, AMAS WA2, and then 2nd May, this is week 7, Tuesday, EMAS WA2. Okay, topics to be tested will be AMAP is, hang on, chapter come in, chapter 13, 14 and 15.1. Okay, and then for EMAP will be chapter 3 and 4. Okay, both are 30 marks test, 45 minutes long. Okay, so for the AMAP one, okay, do expect that while we are testing chapter 13, 14 and 15.1, that's your differentiation. This one is your tangent, normals, rate of change. This one is maxima, minima. And then this one is what we're covering now. Okay, I see that you're very sensitive to this. Alright. All this, okay, chapter 12 is expected. Okay, because chapter 12 is where we learn our chain rule, power rule, product rule, motion rule. Okay, so those chapter 12 stuff are expected. Alright. So although we are not explicitly going to be testing you on those, okay, but any question will actually have those kind of expectations. Right? Okay, then after that for this one, we're still not yet at chapter 4, okay, for your matrices. After we're done with chapter 15, then we go into matrices. Okay? Questions? Yeah? Okay, if no questions, will you please take out your homework? Okay, exercise 14.2. Yeah. Ready? That one is Joshua, right? I don't know what's so amazing on your lab, but maybe you can close it up. Okay. Alright, so looking at exercise 14.2, any issues with question 5? Question 8? Question 8, okay. Question 9? 9, okay. 11? Okay. 13? Okay, so only question 5. Question 8. Let me draw out the diagram first.
So for AMF, is it even though you're not testing chapter 12, still like the expectation? Only chapter 12. Like the chapter 12 is the, that's it. I might understand. You might not.
Okay, could I check that for question 8, right, is the issue in terms of part I and 2? Question 8. Is it? No. So part I and part 2 can? Yes, but that's all. Part 4. Okay, so it's about part 3 for issues and part 4. Okay, can. So for part 2, we are able to arrive at the area P equals to 5x squared over square root of x minus 25. Okay, and then part 3, want to find the value of x. For which P is minimum. And in part 4, find minimum value of P. Yep. Part I also. Any other requests? Part I also? Oh, okay, sorry. Sometimes you're not hit, I cannot see. Okay. Part I, hang on, let me express EC in terms of x and then also AE. Okay, I'm missing something. Okay, so first of all, we need to understand, so for the people who need help with part I, okay, first of all, we need to understand that this rectangular piece of paper is being folded. So this part over here, upon folding, okay, folds upwards. So that means it shares the same area as this part here. Okay, which means that when you do a folding, if you cannot imagine it, you can literally go and fold your piece of paper. Okay, take this edge and then fold it up so that you can imagine what's going on. You will find that this AB being YCF upon folding up, it means that this purple line over here is actually also YCF. Okay, then when we fold it up as well, while this is going to become YCF, this X portion is going to be equals to EF. Okay, so let me use a blue marker. So this line over here is going to be X. Okay, so that's something that you need to observe. So let me write that down. ICF equals to EF equals to X. That's my answer. Okay, then after that CF is actually also equals to 5 minus x because this entire thing is a rectangle. Down here is 5cf minus 3x. So this part here will be 5 minus x. Okay, and then in your triangle CEF, which is a right angle triangle, okay, I will be able to see that x squared equals to 5 minus x squared plus CE squared. Okay, so that means that your CE squared equals to x squared minus 5 minus x bracket squared proceed with expanding. 25. Okay, so that is how we find out what is EC. So that's the first part. Then after that, in that same question, the question wants you to find out what is AE. AE, we have already found it, and that is YCM. Oh, okay. 1 liter, sorry, thank you for that. Okay, so, okay, y a squared plus y squared plus just trying to see whether there's an alternative to this. Y squared. Okay. Okay, so then after that, in order for us to actually find out what is AE in terms of X, which we already know that it is equals to Y, okay, one option is to look at the triangle ADE. Okay, so in triangle ADE itself, we see that 5 squared plus your DE squared is equals to AE squared. Okay, which is our Y squared. Okay, and then DE squared is actually equals to Y minus away CE found that it is square root 10x minus 25. I'm just keeping my CE as CE itself so that it is easier to write. Okay. So now I replace my CE with this part here. So then we can find that y is equals to 5x over square root 10x minus 25. Okay, I'm using a Pythagoras theorem, but using Pythagoras theorem is not the only way. Okay, other way that I have noticed over the years, okay, is that you can do by similarity as well. Okay, but that may not be that easy lah. Okay, I will find that Pythagoras theorem would be easier for us to figure things out for A. Okay. Yes. alternative method. I mark your work, then I give you that comment. Okay, questions? Okay, then going back to the other parts, part 3 and part 4. Okay, find x for which p is minimum. So since we already have p expressed in this manner, that means that I need to do dp over dx first. Okay, so maybe for space constraint, let me erase this part. So part 3, we got to find dp over dx, so apply our quotient rule. So keep the bottom, differentiate the top, okay, minus away, keeping the top, differentiating the bottom itself. Maybe let me just write here. Using your quotient rule, this will be what you get. Okay, not forgetting that when you differentiate the denominator itself, okay, the 2 we keep, power of half we bring down, then power minus 1, so that's why you have a negative half. And not forgetting to differentiate the 10x minus 25, you'll have a 10 outside over here. Okay, now we proceed with simplifying. So in the denominator, when we square, our 2, you remember to square, you get a 4. The square root will disappear because we're squaring it, and hence we get 10x minus 25. Okay? This part, because it's a power of negative half, it goes to the denominator. It won't be more manageable if you know how to simplify it before we equate it to 0 to find the minimum or the stationary value. Okay? So to simplify this, we make them same denominator. Okay, so therefore this part here we multiply with the square root 10x minus 25, I will get a 10x minus 25. Okay, so when you share the same denominator, this square root 10x minus 25 can go down, okay, such that my 10x minus 25 in the denominator is now 1 plus half, so that's 3 over 2. Okay, I'm skipping a few steps over here. Right? But of course, if you want to take things slowly and do it step by step, by all means go ahead. Okay? Because if I do things step by step, I think until tomorrow I still cannot finish these homework questions already. Okay? But of course, if you need time for me to run through this with you again, please look for me after school, okay? Then we will have 200 x squared minus away 500 x minus 50 x squared. That will give us 150 x squared. because the question is asking for when our p is a minimum, so dp over dx must be equals to 0. So when this is equals to 0, that will also mean that 150x squared minus 500x must be equals to 0. Okay. Then in order to solve this, you cannot divide by x throughout. Okay, because x is an unknown, you cannot divide by x. We have to only factorize. In this case, there is a lot of common factors. So I'm guessing it's 50x. Let's try 3x minus away 10 equals to 0. So 50x equals to 0 or 3x minus 10 equals to 0. So x equals to 0 or x equals to 10 over 3. Now we very well know that x cannot be equals to 0. Okay, just writing down the reason here so that we are aware. Okay, because x must be greater than 0 since x is a length as shown in the diagram. Okay, so therefore x equals to 10 over 3. Then, because the question wants you to find out the value of x for which p is a minimum. Okay, we have a value of x over here, but we have not yet verified that p is going to be a minimum. Okay, so you need to go about verifying that this x value indeed gives us p to be minimum. Okay, but then in order to prove that it is a minimum, either we do first derivative test or second derivative test. Okay. In order for us to do second derivative test, it's going to be a headache because imagine what if you did not even go about simplifying, you directly work from here to get this. Okay, then this is going to give you a headache. Okay, when you do your second derivative test. So I wouldn't recommend us doing second derivative test because of the intensity of doing it algebraically. I would rather you do first derivative test. Okay, so by your first derivative test. Just do a little bit below 10 over 3, just minus 0.1 to 2. Okay. Strictly speaking, you should be getting a minimum. Okay, because if you don't get a minimum, that means there's some mistake somewhere. Okay, so using the first derivative test, I will then be able to show that. Okay. When x equals to 10 over 3, you can write it as this number, that's fine. P is a minimum. Okay. For part 4, it is actually a continuation since we're trying to find out what is the minimum value of P. Since I already know that x equals to 3 and 1/3 will give me our minimum value of P, and P is equals to this, so I will take 3 and 1/3 and substitute into here. Okay, but then the challenge will be in terms of the expression insert form. Okay, so to do this insert form, okay, let's do this step by step. improper fraction rather than a mixed number. Just do our simplification first. This one square it. This one multiply. Take note, this is a whole number multiplied by a fraction. That means 10 over 1 times 10 over 3. Numerator times numerator. Denominator times denominator. Okay, so we should get 100 over 3. Please don't make the mistake that we take the 10 to multiply the denominator as well. Okay. Then, where should I proceed next? I erase the first derivative test. I assume you all can do this part all. Okay, we will have 500 over 9 to 100 over 3 minus 25. By all means press your calculator. We will get 25 over 3. Make sure your square root sign covers what it needs to cover. Okay, then this is 500 over 9 divided by this thing. This denominator actually can come down. So 9 times 2, 18. And then think of ways to make things easier for you. Okay, I just break out this fraction. 500 over 18 square root 25 over 3. I rewrite it as 500 divided by 18 square root 25 over square root 3. Okay, because in this square root 25 over 3, I can break it out into square root 25 over square root 3. Okay, then 18 times square root 25, the entire thing divided by square root 3. Alright, so this part is the same as this. Square root 25, we know that is equals to 5. Okay. Then we know that dividing by a fraction, it causes the fraction to split. 18 times 5 is equals to 90. Okay, simplify. Nothing more to simplify, right? So 50 over 9 root 3. Okay. So the minimum value of P is 50 over 9 square root 3. It takes some time to look through the answer. Any questions? Okay. simplification part. Am I right? The simplification part. Okay. The simplification part will definitely rely on your very strong understanding of your numbers. Okay. I really recommend that you do things step by step. You cannot get by things without going through the hard rigor. Okay, the difficulty part. Right? So if you don't try it, you just give up, then you will never be able to actually overcome this challenge. Okay? Right? Let's look at question 9, shall we? Okay? For question 9, could I just check, is it part I that is the issue or part 2? Can I get a show a response? Is it part I? Question 9? Part 2, is it? You're all looking at me. Am I asking the correct question? Is it part I or part 2 or both? Both. Okay? Yeah. Alright, part I, you must remember what is a cylinder and the formula for volume of a cylinder. So, a cylinder is the one that has a round base and straight out. Okay? It says that it has a height of h and radius r. Okay? Then it has a fixed volume of 400 cm3. In part I, we want to show that the total surface area A can be given by 800 over r plus 2 pi r squared. Okay? So, to do this, our volume formula for a cylinder, we shall let V represent that variable. Okay, V will be equals to pi r squared times height, because formula of a prism is base area times height. Okay, so you can write it as pi r squared h, that's also fine. So our volume is given to be 400. So 400 equals to pi r squared h. Okay, notice that our area is in terms of r, there is no h. Okay, so that means that I would eventually need my h to be in terms of r, which we can get 400 over pi r squared. Okay. Then the formula for the surface area of a cylinder. In a cylinder itself, okay, first of all, you must know what is a cylinder. Okay. Before then after that, you can know that cylinder can be formed by using a paper, you roll it up. Alright, to help you remember what is the formula for surface area of a cylinder, we must know that there are two circles, front and back, so pi r squared, pi r squared. Then it is about the curved surface part, okay, that will likely you tend to forget. Okay, but if we know how to roll the paper, we know that when we roll out, it is a rectangle. Okay, and when we roll out, the length itself is the circumference of the circle, and the breadth itself is none other than the height of the cylinder itself. So, area of rectangle, length times breadth, your length is now circumference of the circle, 2 pi r, and then your breadth itself is the height. So therefore, your surface area A will be 2 pi r squared for the two circles at the top and at the bottom, plus, okay, the area of the rectangle, which is made up of 2 pi r times h. Okay, so this is area of two circles. This is your length of rectangle, and then this is the breadth, whereby the length is circumference of circle. Okay, and the breadth is the height. Okay, so then your h, you have already found that it is actually the same as 400 over pi r squared. And we will have 800 over r upon simplification. Okay, so and then we have shown it. the volume surface area of prisms, cylinders, spheres, cones, pyramids and all that is a very common expectation when it comes to A maths, especially in calculus. So if you struggle in remembering them, I suggest, okay, one shot, go and find all those formulas. Those are things you learn in set 1 and set 2. Okay, go and find them out. Write it inside the mini problem booklet I've given you so that you can start remembering it on the go. Okay? Then in part 2, we want to find the value of R that gives the cylinder a minimum surface area. So it is actually the same thing again. dA over dR equals to 0. So we need to find out what is dA over dR. Okay. So upon differentiation, you should get 4 pi R minus 800 over R squared. Will be equals to the cube root of 800 over 4 pi. You can simplify 800 over 4 pi. over pi. Okay, so the value of R will be equals to that if you leave it in exact. You may leave it in decimal if you want to. Yeah, go. Okay. Then we need to go about finding out that it is going to give you your minimum area. So you can go and differentiate this again. So 4 pi plus 1600. In this case, because doing your second derivative is fairly easy, okay, but then if you choose to do first derivative, that's perfectly fine as well. Your second derivative will be equals to 12 pi if you want to find it in exact, or if you use calculator, that's perfectly fine as well. Okay, since we only want to know the value, that will be 37.699 more than 0. Therefore, your A is minimum when R equals to cube root 200 over pi. You may leave it in 3SF. That will be fine. Okay. Questions? Okay, could I just do a check that question 11 and 13 is the issue concerning the forming of the expressions? Okay, not so much about proving that it is minimum, maximum, or finding the value anymore. Is it? So it's really about the forming of the equation. Okay, then I'll just cover for question 11 and 13 the first few parts in terms of forming the equation. Okay, I think that the next few parts is all repetitive. It's always equal to 0, find first derivative equals to 0. Okay, then after that, use second derivative test to prove or your first derivative test. Okay. Okay, question 11 part I, we want to find H in terms of R. It's important to take note that the question gave us volume of cylinder, not the volume of the entire diagram. Okay, so again, volume of cylinder is pi r square H. That is equals to 96 pi. Okay, so since we want H in terms of R, it will be 96 pi over pi r square. Can cancel out the pi. And we get 96 over r squared. Okay. Then in part 2, we want to find the total surface area of the entire thing. Okay, so in part 2, total surface area A is made up of the surface area of the cone and then also the surface area of the cylinder. For the cone, it will be pi RL. Okay. So this is formula for curved surface area of cone, formula, plus curved surface area of the cylinder will be 2 pi RH. Just putting down the formula first. And for the cylinder, we only have one circle. The top circle doesn't count because it is not exposed. We cannot touch it. Okay, it is not a surface of the figure. So we plus another pi r squared. Okay. L in this case is your 3R. And then H has been found to be 96 over R squared. And then we simplify. So 3 pi r squared plus pi r squared gives us 4 pi r squared. Okay. And then we just have to factorize out 4 pi. And we are able to show what we want. Again, volume is equals to 12 cm cube. Volume of any prism is base area times height. In this case, the base is actually a triangle, and this triangle is not a right angle triangle, it is an equilateral triangle. So don't make the mistake, okay? So in an equilateral triangle, we have to draw it out. Okay, in this case, it's x on all sides. Okay, to find the area of an equilateral triangle, we must know that when I cut it into half like that, I do get two congruent triangles. Okay, and then this will actually be x over 2, down here x over 2. Using my Pythagoras theorem, I will be able to find out the height, and that will actually be that. let the height be y up. So y square plus x over 2 square equals to x square. Okay, and then your y is equals to square root 3x squared over 4. Okay, so the area of triangle will be half times base times height. Okay, and we get square root 3x squared over 4. Okay, and then the volume will be the base area, which is the area of the triangle, times the height h. Yeah, these are any information. Okay. Oh, okay. So volume is given to be 12. This will help me to express h in terms of x. Okay, and then the total surface area S will be the area of the two triangles. So 2 times okay, and then plus the area of the 3 rectangles. Okay, there are 3 rectangles over here. Each one of length x and breadth h. So that's 3hx. Okay. Then we do our rationalization. Can be divided by 3. Okay, and then we'll get the answer already. Alright, I don't have the space, but the next step is just answer. 144 divided by 3 is giving you 48 in the numerator. Okay. In case you're not sure how to do part 3, part 3 is asking explain what will happen to the cost of the aluminium, okay, used if the value of x were to be arbitrarily chosen. Arbitrarily chosen means that it's just anyhow choose one number lah. Okay, instead of taking the one in part 2. Okay, so the one in part 2, if I take the value of x, it is expected to give us the cost to actually be the minimum. If we take anything that is different from the x value, our cost itself is going to be higher than the minimum cost. Okay, so that is the consequence of choosing an arbitrary x value. So you just have to explain that the cost of the aluminium used will be higher. Stop. No need to go too far in terms of explanation. Right? Because your x value in part 2 should give you minimum cost really what. Anything else will actually be higher. Okay? Alright, if you're done, please submit your homework to the front. Okay, if you still need some time to complete any remaining parts of the question, then please put it inside my locker by the end of today. Looking at the time now, I definitely cannot do chapter 15 anymore. So we will have to keep that on hold till tomorrow. Pass it down.